Hi, this is Mike with Actifio. Today we're going to be talking about Oracle RMAN, backups, different methodologies for backups, some of the pros and cons of each, and we're going to dive into how Actifio has implemented Oracle backups and recovery. So to start out with, there's really three approaches for Oracle backups. You have your traditional approach of fulls and incrementals, you have a storage snapshot approach, and you have the incremental merge method, which is often called incremental forever. Traditional method, fulls and incrementals, really nothing unexpected here. You get a full copy of an Oracle database. You usually use Oracle RMAN to get it. That full copy is a standalone copy. It has everything that you need in there, including some archive logs that are generated during the full copy. If you want to use this full copy, to create it, you're copying from the backup server, from the Oracle server to whatever backup target it is. This might be disk attached to your Oracle server. It might be a backup server, whatever. In order to do the restore, you reverse the process. The data gets copied back. To help the process out a little bit, Oracle has incrementals. You might create an Oracle incremental, 1 or 2 or 3 or more, in between fulls. And you would do that, of course, to minimize your backup window. An Oracle incremental is fast and efficient. Since Oracle 10, it uses change block tracking so that it doesn't have to go and look for all the changes. It just knows what the changes are. The downside, of course, to this is while it helps your backup window, it hurts your recovery times, because now your recoveries don't just have to copy a full copy, they also then have to roll in all of the incrementals that have been taken since that full copy was created. So that approach has been around for a long time. It's very well proven. It's actually very well proven to be not effective with really large databases, which is probably why you're watching this in the first place. So that brings you to option number 2, storage array snapshots. The pros of storage array snapshots are they're very fast, right? Taking a backup is as simple as taking your group of disks that are sitting underneath your Oracle database and taking a snap. You put the database in hot backup mode first, take the snap, take it out of hot backup mode, and do a short archive log backup so that you get consistency. Contrary to popular belief, putting a database in hot backup mode doesn't actually prevent writes from taking place. The data will still be inconsistent. It's just inconsistent after a known point in time. Therefore, you can use the archive logs to make it consistent. Benefit there is, of course, the speed. The downside, on the other hand, is it's now very linked to your storage design. So your LUN layout underneath your database. And if you add a disk, well, you need to be sure that that's included now in here, maybe either through some automation or whoever set it up. Accessing the data is, of course, very fast, but usually takes a storage type person because you've got a disk copy and now you need to present that someplace to use it. You have to turn that into a database, bring it online. Usually DBA gets involved with that. You also now have risk because this is a single point of failure. It's your production storage array. And while we all like to think production storage arrays are never going to go down, the reality is we've all probably experienced one going down at some point in our career. And then finally, you have cost on this because retention on here is going to be relatively short due to the fact this tends to be expensive storage. So your short retention means you need to make another copy. So not only are you consuming some space on your storage array, but now you're going to be making probably fulls from here, maybe every day, to get a longer term retention someplace else. So it's like incrementals, it's a step towards better backups. This does a much better step towards restores of recent data, doesn't fully address the cost aspect of things just yet. And that brings us to incremental merge. So incremental merge varies a lot by customer implementation, by vendor implementation. And incremental merge is basically a feature that Oracle introduced a while back where they say instead of making a full copy, make something called an image copy. And this image copy is a runnable copy of your database. It's not in a backup format like a backup, like a full backup is. It's that runnable copy. And this gives you the ability now to take an incremental and roll it in to that image copy. Now, why would you want to do that? Well, when this was first introduced, Oracle had published a paper that said, if you want to have fast incremental forever backups, you can simply do an image copy followed by a series of incrementals, and as many incrementals as you want, that's your retention period. If you say wanted 5 recovery points, you'd have your full and 4 incrementals. When you take your 6th incremental, you roll in the first one, effectively bringing your full copy forward one day. When you take your 7th, you roll in your second, again, bringing it forward. So you have this rolling rotation of retained data. It's very similar to what you can do with a snapshot, except it is now somewhere else. And that means you eliminate the single point of failure. You may have it in lower cost storage, so you might be reducing that storage cost a bit. It still has some downsides, of course. Some of the cons on this approach are you're still leveraging your Oracle server to do some of that work. It's running the incremental, it's doing the merge, whereas the snapshot-based approach has almost no burden, no load on that production server. So there's a little bit of a trade-off there. This does tend to scale a little bit better, but it has some hang-ups due to this retention approach, and in particular, the issue is recovery time, because if you want to get your most recent point in time, which is typically what you want most often, you now have to roll forward every incremental that you've got, which makes it actually slightly worse than recovering from your full when it comes to incremental roll-in time. Now, the benefit, of course, is you're starting with something that's in a runnable format, so you don't have to copy it somewhere to use it. You can actually present it and use it from your backup medium. So that introduces us to some of the topics there. Let's talk about Actifio specifically now. So when it comes to Actifio, what we said was we want to make sure that the solution we provide is fully automated, fully reliable, doesn't rely on any reverse engineering, for example, of data structures inside the Oracle database. We wanted to leverage this incremental merge process, but we wanted to do it in a way that eliminates some of the downsides even here. And so what we did was we said, we're going to have an Actifio appliance. This Actifio appliance is going to present storage to the Oracle server. It, of course, is backed by some backup storage. Now, that backup storage can be whatever tier you like, sort of like the incremental merge approach here. And what we'll do is we'll do the initial image copy, create our full copy here. Now we have a full. Now, at the end of that, we take a snapshot and call that day number 1. Every time we run a database backup after that, we simply do an incremental and a merge into the copy that's coming from Actifio. That updates our top copy here to be the most recent point in time, and then we take another snapshot of it. So rather than roll in the incrementals at the time of recovery, we're effectively rolling in the incrementals at the time of backup. And what this allows us to then do is say, any point in time that you want, you can simply select it, present it back to an Oracle server, and bring that database online right away. We also implement it in such a way so that we can integrate with Oracle ASM. And when we do that, what we do is we say ASM format here means put the data in ASM format here. It's not in a backup format, it's right in ASM. That gives us a few benefits when it comes down the road to recoveries we can talk about in another video, but more importantly is we don't have to have this in ASM format if this is, and we don't have to have this in file system format if this is. We can actually switch. So a database in ASM format in production, if you have a test environment that maybe you want to run file system on, you can have Actifio store this in file system format here, and then when you go to use it elsewhere, it can be in that file system format. We can also do the vice versa. As long as ASM binaries are installed here, if your database is in file system format, during the image copy and the incrementals and merge, we can be storing it in ASM format to enable you to use it in that ASM format. Fully compatible, of course, with Oracle RAC, both on recoveries and on backups. But finally, and probably most importantly here is, when it comes to retention, all of the different options here have kind of fallen down a little bit. And what we've done is we've implemented so that we generate a list of deltas between each of our snapshots here, and then we allow you to send them somewhere else for long-term storage. So this might be cloud, it might be deduplicated disk. We offer many choices, but even if this is something like Amazon S3 in the cloud, you can say, I want to keep my longer-term copies out here and only keep maybe a week's worth here or a month's worth here, yet we still allow you to pick this point in time, for example, and present it right back to a server and bring that database online again without first having to copy it to your local copy and then back. This can even be an internet connection bringing that database online. So lots of flexibility and functionality around long-term backups, long-term storage, and efficiencies to only be sending deltas, incremental forever, even when we're sending data out to the cloud or into that dedupe pool. A few final thoughts. This solution was developed in Actifio by DBAs for DBAs. We have a number of DBAs on staff who lived, especially in the financial industry, lived through the pain of all the different methods that were out there at the time and really wanted to do something better. And this is ultimately what the solution has come up to be. We also wanted to make sure that everyone knows the one big mystery about incremental forever tends to be data integrity. Everyone talks about data integrity. Everyone says, RMAN takes care of that for you. It does all sorts of checksumming. And it does to a point. But at the end of the day, if you have a block of storage that since the day it was created has never changed, it's never backed up again, you still want to find out and validate that it's correct, that it's not been lost or corrupted. Actifio has a patented fingerprinting technology that we have implemented so that every image that we take, every backup image, we read from the production copy a selected set of blocks, different every time, generate a unique fingerprint based on those blocks, and then on the Actifio side, we read the same blocks after we've copied them, generate that fingerprint, and we actually store the fingerprint along with each one of these images on separate disk in a separate place, but associated with each image. And then every time you access the image for any reason, for recoveries, for a test environment, for a future backup, we recalculate by rereading all those appropriate blocks, rechecking the fingerprint still matches what the original one did, so that you can have that confidence to know that despite the block never being written again since the original time, it's still valid and available for you. Thanks for listening. We hope to talk to you again soon.